Hey everybody, this is Professor Ross, and in this video we're going to be talking about paired designs. So let's take a look at some notes here. Our key learning objective for this video and this unit is going to be using the logic of statistical decision making. And so we'll be thinking a little bit about how we have designs that can be slightly different, even though we may have the same types of variables as we've seen before. Particularly, we're talking about when we have a quantitative response for two groups, and we're going to have two possibilities here for design. This is when we have one binary categorical explanatory variable and one quantitative response variable. We have already looked at the case where we had a binary categorical explanatory variable and one quantitative response variable. We said, hey, we can compare the means of two groups. So we're still talking about this idea of comparing the means of two groups in some sense. However, previously, we assumed that in our scenario, each quantitative value was independent. So for example, we could be thinking about students taking a stats quiz, let's say, and we might set up an experiment where we randomly assign students, half the students to listen to music while they take the quiz, and the other half the students to not listen to music while they take their stats quiz. And then afterwards, we might check their scores. The two different groups of students, ones that listened to music and the ones that didn't, were independent in that I don't think how a student in the group that was listening to music, I don't think how that student scored should have anything to do with how a student in the group who was not listening to music scored. They're independent of each other. And that's the kind of scenarios we tended to look at and analyze previously. But now we're going to talk about a new possibility. There's a possibility that our quantitative values are actually paired with each other. This would require a different kind of design for the study. And so here's another way we could do this study. We could have every student do a quiz where they're listening to music, and every student do a quiz when they're not listening to music. And then for each student, we'd have two quantitative values, one for when they listen to music and one for when they didn't. Let me show you an example of what that data might look like. With the independent groups design, you'd have student one who listened to music and they had a score in their quiz. Student two also listened to music, they had a score in their quiz. Student three, they got selected to not listen to music and they got a score in their quiz, etc. In a paired design, what we would have is student one had a score for a quiz where they listened to music and a score for a quiz where they didn't listen to music. And student two, vice versa, or excuse me, the same thing, and student three, etc. So every student would have two scores, one for with music and one for without music. One of the keys to paired design is that we want the students to be randomly assigned to either be listening to music or not for a given quiz. So for example, we don't want all the students to listen to music on the first quiz and all the students to not listen to music on the second quiz, because then it might be something about the first quiz that was different or the second quiz. We want to randomly assign them for each quiz. Student one listens to music on the first quiz and not on the second, but student two would be the opposite, music on the second quiz and not on the first. So that way we get a mix of it of things, and we're not associating one of our groups with something other than what we're interested in. So this is how the two designs differ. There is a big advantage to paired design in that I don't have to worry about, for example, students one and two here have kind of lower scores and they listen to music, but student three had a higher score and didn't listen to music. I don't have to worry about this possibility that student one and two are just kind of weak students. Maybe they don't really understand what's going on in the course, and that's why their scores are lower. And student three is really on top of things, and that's why their score is higher. Because over here in the paired design, student one, who presumably is the same kind of student for both of these quizzes, is going to have scores for both. And student two, who apparently is just not doing well in the course overall, has scores for both. And student 3, who seems to be doing a little bit better overall, has scores for both. So now the differences between the students are mitigated by the fact that I have each student giving me a score for both, and I can pair these two together. What I then become interested in is less the individual scores on each group, but instead I become interested in what their difference was. For example, if I just subtract and look at the differences uh, between these two, and I get really interested in what's going on in these differences. Am I going to see some kind of consistent difference happening, or am I going to see kind of things all over the place? If I see, for example, all positive numbers coming out, that means they're doing better with music. Or if I see a lot of negatives coming out, maybe they're doing better without music. And we can take this difference value and we can analyze that. More on that in the next video, what we get to do with this data. But that's the idea behind paired design, what we want to do with it, and why, a little bit of why there's an advantage there. One of the biggest things that I'd like you to come away with here is being able to think about the two different designs and understand what each design is like. So I've got a few examples here for us to think through, and to think through what a paired design might look like versus what an independent groups design might look like to try to answer a certain question. So I'm going to pose a question. I encourage you to pause the video and try to think about what would a paired design look like for this. And then I'll share my idea, and then we can move on to independent groups and think about that. So how well does a diet produce weight loss? Think about what a paired design might look like. One possibility here would be that you would have all participants in your study spend 1 month on a diet, and they'd also spend 1 month off the diet, and we'd check the weight loss after each month. And we would randomly assign them which one they would do first, off the diet or on the diet first, and then we just check each. That way, all participants would have 2 scores. They'd have a weight loss with the diet and a weight loss without the diet, and we compare those 2 scores together. Think for a moment what an independence group design might look like. So here we'd have 2 groups. Half of our participants would spend a month on the diet. The other half of the participants would be the control group, and they would not be on the diet. And we'd check the weight loss after a month for all of our participants. So here we've got 2 separate groups. We don't get 2 weight loss scores for the participants. We only get 1 for each. And that's an independent groups design. Once again, the advantage of the paired design is that a given participant might be really predisposed toward weight loss, or might be really predisposed to not lose much weight. The paired design lets us pair those data together so we can compare how they did on and off the diet. Versus independent groups, those differences are still present in each of the groups. Let's try another one. Our price is different at 2 grocery stores. Maybe we want to find out if one of the local grocery stores tends to be more expensive than the other. Think for a moment what a paired design might look like. Here for a paired design, what we could do is check prices for the exact same item at each store. For example, we go in, look for the 12-ounce bag of Doritos at each store and check the price. Then we'd get a pair of scores that we could compare to each other. Think about what an independent groups design might look like. For independent groups design, we'd have a random sample of items selected at each store and check the prices for our random sample of items. So here, to me, this one's really clear, the advantage of the paired design. We know we have the exact same item, and so any difference in the prices can help suggest which store might be more expensive. Whereas if we do a random sample, it's possible that there's some fluctuation in the randomness of our sample, that we're randomly picking some more expensive items or some less expensive items. Hopefully, if our samples are big enough, that wouldn't be a big deal. But clearly, the paired design takes away that problem altogether. So that's an advantage of the paired design. Let's try one more. Do married men or married women tend to watch more TV? Think about what a paired design would look like. Here, we might have husband-wife pairs record how much TV they watch. So, Bob is married to Betty, and we get Bob's amount of TV watched and Betty's amount of TV watched. That pairing now, instead of, for example, one person repeating the same thing or having the exact same thing, we have slightly different things. Husband and wife are not exactly the same thing, but they are paired in a very natural way, and we might expect them to, both tend to watch TV together because they're married. So we might expect this pairing to reduce the kind of variability we'd see between different groups. And instead, this pair, husband-wife, becomes one observational unit that we got two results from, the husband's amount of TV and the wife's amount of TV. Think about what independent groups might look like. Here we'd have a random sample of married men, whoever they're married to, that doesn't matter, and we'd find out how much TV they watch. And we'd have a different random sample of married women, and once again, it doesn't matter who they're married to, just that they're married women, and we ask how much TV they watch, and then we can compare the average amounts of TV. So once again, we get that advantage of pairing that the pair together might not be that different from each other. So hopefully you're getting a sense of the difference between paired designs and independent groups. With paired designs, we have a single observational unit that we get two results from that's paired together versus independent groups where we have two different groups of our observational units that we're getting a single result from each. When should we use paired designs? We actually want to use paired designs that give us an advantage. They reduce the differences that we tend to not be interested in. For example, if you think back to students taking the quiz, we want to see if it's really music that's affecting the quiz or not the differences in students' amount of knowledge of the content. So pairing it reduces those differences for us. So it's really good to use paired designs when we can. When can we use them? Well, when it's possible to use repeated observations is a great time to use paired designs. For example, if I can give students one quiz and then a while later give them another quiz and randomly assign them to listen to music or not on one of the two quizzes, that's a great time to use it. It's also great to use paired designs when we expect a strong association between repeated observations within the pair. So if we had some thought of like, well, students might just really not be in the same place when they take these two quizzes. Maybe you give one quiz at the very beginning of the course and the other quiz way at the end of the course. We might not feel like there's as close of a connection between those repeated observations. However, if we could do the quizzes in back-to-back weeks and then repeat those observations, we might feel like there's a connection between that student hasn't really changed that much between our repeated observations. It's also great to use paired designs when we can create natural pairs. So if we've got scenarios where we don't have the exact same individual doing repeated observations, but we have some natural pairs, we have identical twins, or we have siblings that have grown up in the same environment, or we have a husband-wife pair, or we have some other way to create natural pairs, that can be a good time to think about using paired design. One final comment, using paired designs requires slightly different analyses than independent groups, and I hinted at that earlier. So one thing to know, it does make a difference on how you analyze your data, whether you're using paired designs or independent groups. And so understanding what design you have and being thoughtful about how you choose it makes a difference in how the rest of the analyses go. So it's really something you want to understand. Hope this video has helped you understand and learn a little bit about paired designs.